Hi, my name is Brad. I'm a Principal Security and Compliance Specialist with Amazon Web Services Public Sector. And what that means in plain English is I work globally with our public sector customers on issues that deal specifically with security and compliance. And today I'm going to talk to you about using trusted internet connections for sensitive workloads in the government through the lens of the TIC3 initiative for the US federal government. So first, a little overview about what TIC is and the history of the TIC program for the US federal space. TIC started off in 2007 with the TIC1 version, and it evolved into the next iteration, which was TIC2 in 2011. And TIC2 had a significant amount of controls that were prescriptive in nature as part of the TIC2 framework. Meaning that there were specific elements, specific software, specific hardware that was supposed to be utilized in order to become TIC2 compliant. The feedback from the community was that for TIC 3.0, a more outcomes-based desire was made, and the team wanted to make sure that for TIC 3 moving forward, the standard would be agnostic to particular sets of hardware or software, and instead rely strictly on an outcomes-based control model. So the biggest difference in plain English between the previous versions of TIC and TIC 3 is that TIC 3 is very much focused on the outcome, and TIC 2 and previous were very much based on specific controls. So what really is the biggest difference then? Well, the biggest difference is that unlike the previous versions of TIC, there are no longer specific controls that are called out as part of the documentation. Instead, customers leverage a set of workbooks as well as overlays from other foundational frameworks. So as an example, if we look at this slide, which gives us sort of a way to take all of the data that would be part of a trusted internet connection design for customers that are using the TIC3 model, first, they apply architectural design patterns from the use case that their application will be designed for through the lens of the Nist CSF. And the benefit to the Nist CSF is that the CSF is used both inside of the US federal space, but also as a standard framework globally for customers that want to rely on the common security frameworks, controls, and design choices. The next is for the individual security elements, there is the security capabilities catalog. And what that outlines are the individual sets of technical requirements as part of the TIC 3.0 framework. And this is also done in conjunction with evaluation of NIST Special Publication 853. And then finally, customers can use overlay models that are provided not only by AWS, but other partners as well to understand how to use a solution for a trusted internet connection. And again, this is done by evaluating all three of these areas: architecture, the requirements from the workbooks, as well as the overlay models. And then those are all blended together from an agency risk management team to make an evaluation of whether or not the design has successfully met the requirements for the TIC3 design. One thing that's different from previous versions of this trusted internet connection design as opposed to previous designs is that TIC3 no longer has an official accreditation. Instead, it's based on self-attestation. So an important call out is, again, that focus of that agency risk management team to evaluate all of these data and control to make sure that the application or environment is indeed compliant. So that begs the question, how do I then develop for compliance for a TIC3 or trusted internet connection compliant workload? And the way that we do this is through evaluating the different security objectives that exist within, in the case of TIC3, the security objectives portion of the framework. The first part is to deal with traffic management. And for traffic management, that really deals with the observation, validation, filtering of data, and continuously making sure that all activities that are taking place on the network are least privilege and default deny. And as we dive into AWS services, the benefit to an AWS customer is that the default posture for many AWS networking services is exactly this. The posture is always default deny until a customer specifically authorizes the service to allow ingress or egress. The next is to protect traffic confidentiality and making sure that only authorized parties can discern the contents of data in transit and that the sender and receiver identification and enforcement exist. So the good news for AWS customers is that there are strong traffic confidentiality controls that exist within the platform, and that allows customers to use TLS ubiquitously, not only for services that are under a customer's control through mechanisms like the certificate management service, but also the ability to protect data at rest using services like Cloud HSM, KMS, and customer-supplied encryption solutions. The next is around protecting traffic integrity and making sure that traffic alteration of data in transit does not occur and that we detect altered data in transit. And again, this is an overlay using TLS connections that exist for the application-to-application communication, but also from an AWS API perspective, this is a good example of AWS's use of the SIG-v4 process to validate API calls that are occurring on the platform so that we can make sure that we have a positive confirmation of the user and principal that are making a call to the environment. Next, we want to make sure that we have ensuring service resiliency and effective response. And really from an AWS perspective, that really means making sure that we design our applications so that it can withstand any unforeseen outages. So we have continuous operation through AWS best practices like distributing across multiple availability zones. In some cases, the use of multiple regions. And from an effective response perspective, as we see when we start to go through some of the overlay models that we have for our trusted internet connection designs, you'll see that we're able to use automation through a number of different services, but most commonly we use a service called Lambda to deliver the automation. And we'll dive into that in just a little bit. So all that to say, can you give me some specific examples about how I can use specific security objectives and map them to AWS services? So the good news is that we have done this for all of the different security objective solutions. And for today's presentation and for timeliness purposes, we're only going to go through a select handful. But for customers that have additional questions, we encourage those customers to reach out to their account team to engage with your solutions architecture team or specialist community that can help you understand how to implement these controls. So from a management of traffic perspective, we do that through first the use of AWS VPC flow log data, and that allows us to look at NetFlow-like information traversing the VPC environment, making sure that we understand what is moving inside of an AWS network. We also have the ability to constrain that traffic using security groups. And security groups are stateful packet filters that wrap around resources that exist inside of the VPC. Also, a newer feature that was released earlier this year, the network firewall solution, allows customers now to place a network firewall device inside of the VPC that will allow them to control traffic ingressing and egressing that VPC in a model that is very reminiscent of an inline intrusion prevention service. So this allows customers great flexibility to not only control traffic at the lower level, like security groups, network access control, monitoring through VPC flow logs, but now also the ability to control traffic centrally via the network firewall solution. So we also want to provide customers with the ability to take that data and then react to it when we see anomalies. And so we do that through centralized log delivery of that VPC flow log data, looking for inbound or external IP deny traffic. So in plain English, a good example would be if I have two EC2 instances that are in the same subnet that don't normally communicate with each other, but suddenly we notice in the VPC flow logs that the EC2 instances are failing in the VPC flow log as a deny statement to communicate with each other in an east-west direction, then we know that something maybe anomalously is occurring inside of that environment, and we may choose to stop those instances so that we can go and perform an investigation. The next is the ensuring of an effective response. And as I mentioned earlier, anytime we talk about automation on the AWS platform, you'll often hear AWS solutions architects talk about Lambda. And the reason that we use Lambda so ubiquitously is the ability to spin up a function that no longer relies on server infrastructure. So customers don't have to deal with the undifferentiated heavy lifting of standing up a complete EC2 instance only to run a select set of, for example, Python or Ruby scripts. And instead, they can use that service to allow them to control the environment so that they'll be able to control that automation throughout its lifecycle and respond to events in near real time. As a few other examples from the universal security capabilities perspective, first is backup and recovery. So the AWS solution that we feel maps to the backup and recovery objective is the use of AWS config and AWS CloudTrail logs. And what that does is it allows us to not only provide information about resources inside of the environment, but it also allows us to record all of the operations that occur inside of the environment through the use of CloudTrail logs. So what that means in sort of plain language is that we can use the AWS config service to give us the full provenance of how a resource was created, used, everything that was attached to it, and then ultimately destroyed. And at each step, who was the individual that created that resource. From a least privilege perspective, we now have the IAM Access Analyzer and Access Advisor tools that exist within the IAM console, as well as the AWS config service as well, for making sure that we use configuration controls to look for things like policy changes for IAM principals, and also for creating automated alerts when deviations occur. So another plain language version, when we have a situation where a principal maybe changes a policy on an IAM user that's not part of, for example, the identity team, config can detect that non-compliance and then fire a Lambda to automatically remediate that finding. As another set of examples within this environment, if we look at the universal security capabilities again, from an inventory perspective, again, we use AWS config and systems manager. The difference in this case is the use of systems manager to be able to give us information at the detailed level for the EC2 operating system. So a good example in sort of plain language is the ability to use Systems Manager to describe all of the different services and all of the different libraries that are installed on the server that's being used. But an interesting call out for customers that are still in mixed use environments where they are both on premises as well as in the cloud is that you can use Systems Manager outside of AWS as well to help gather that information about how systems are configured. So this gets inventory about how the environment is configured, and then again, all of that log data can be centrally stored and processed. From a centralized log management, we would do this using S3, CloudTrail, and Amazon Elasticsearch. So S3, as you may know, is a highly cost-effective storage solution that allows customers to store vast amounts of data for very little money. And the benefit there is that we can store large amounts of log data that can be generated from services like CloudTrail, but also the ability to long-term archive data from operating systems like syslog data. And then next we go into the policy enforcement capabilities. And so in this case, when we look at things like DDoS protection, this is where we would leverage services like AWS Shield and AWS WAF. And then we also have the ability to do DNS sinkholing now with Aws Network Firewall. So in the situation where we have a threat for example, a new malware variant or an indicator that makes exist for a certain vertical, such as the healthcare market with a particular type of ransomware. When we know what those command and control servers are, we can now effectively block those traffic via the network firewall rule sets to explicitly deny any resource within the VPC to be able to communicate with that DNS entry. Next, we go on to the dynamic threat discovery capability, and this is where we'd use services like Amazon GuardDuty, Security Hub, and Detective. And the way that we would do this is through, first, the enablement of Amazon GuardDuty, which gives us a managed threat intelligence view of the account, which can be centrally aggregated to a singular parent account inside of an organization. And then to blend that data with other log sources using a service like AWS Security Hub. And then when we do have an anomaly occur, we can use a service like Amazon Detective to go back and actually understand how a vulnerability perhaps was exposed in the environment, and to allow investigators to do more research to understand if an anomaly is something that was expected or unexpected inside of the environment. From a patch management perspective, again, this is where we would use AWS Systems Manager, which allows us to create patch baselines that allow us to focus on different levels of severity, as well as being able to apply patch baselines for different types of fleets. So in plain language, what that means is I can set a priority so that all servers that, for example, hold mission-critical data or regulated data must be patched in a window of no later than 24 hours. But for web services that are more transient in nature or that don't contain sensitive information, we can put them on a more delayed patch cycle, such as every weekend at an off hour. So within the TIC3 framework, there are a concept called trusted zones. And where AWS differs a little bit from the prescriptive guidance of the TIC3 framework is that while the TIC3 framework describes the use of trust zones in a high, medium, and low environment, AWS is increasingly moving to suggest that our customers instead embrace a more zero trust model. And what you'll see through some of the reference architectures that we'll be providing in a moment, as well as other talks that are occurring this year at reInvent, is that we want to have customers start to move to a more microservice architecture where instead of relying on the network as the perimeter, we consider all of the different resources in their totality and the way that they communicate with each other in a lens that uses least privilege and making sure that resources only communicate with explicit resources that are done through proper identity authentication and authorization. So the way that we roll all of this up for TIC3 is through combining all of these different objectives through the lens of the Nist CSF. And the good news is that AWS has a number of previous talks on Nist CSF, and we would encourage you to go back and watch some of those past sessions. A few specific callouts within the CSF is that when we look at the pillar, for example, the identify pillar, you can see that we have done a fairly exhaustive mapping of the different elements within the Nist CSF identity portion to AWS specific services. And likewise, when we look at things like the Nist CSF protect portion, we can see that AWS has done a fairly exhaustive set of mapping exercises for different services that would align with the different specific controls. So as a call out, for example, you can see that from a maintenance perspective, we have things like AWS config and systems manager, just like we did in some of the previous examples that I provided. Next is on to the Nist CSF detection portion. And again, when we look at the detection processes, again, we can see some familiar services from previous descriptions, things like guard duty, Macie, Lambda, and the ability to then blend all of those through events in CloudWatch events. And then next we move on to the Nist CSF respond portion. And so again, the biggest portion of this is that making sure that when we respond to an environment, we do it in a way that is thoughtful and making sure that we embrace automation as much as possible. So one of the biggest problems that we face as a security community is security practitioners sort of burning out. And one of the reasons that that occurs is people get really tired of having to deal with tickets and making sure that, for example, patch was applied or that, there's a finding for a security group which is against company policy. When your team knows what the response should be to one of those findings, we want customers to, as much as possible, automate those responses rather than having a human in the loop. And the benefit to that is that that automation allows you to then respond to those in near real time, but also allows those humans inside of your environment to focus on more heavy cognitive skills rather than chasing tickets. And then next we move on to the Nist CSF Recovery Phase. And so this is really around making sure that we have a strong recovery plan. And again, AWS has a series of previous talks that deal very much with AWS disaster recovery and how we can apply disaster recovery techniques inside the cloud. So this slide really speaks to the various AWS security-specific solutions that exist for identity and access management, detective controls, infrastructure protection, data protection, and incident response. So the key takeaway here is that for each one of these areas, you can see that we have a multitude of different services that allow customers to meet those needs. So let's move on to the actual important part here, which is how do I develop a trusted internet connection solution for my government environment? So one mechanism that will allow you to do this with low friction and pain is to develop compliance as code. And one example of that is through the use of AWS CloudFormation templates. And what that will allow you to do is standardize the deployment of specific controls and techniques that will allow you to meet those regulatory requirements. So in plain language, the ability to ensure that the security operations team has a dedicated role inside of the environment that they can use in the event of a emergent situation, but also to gather telemetry data inside of the environment. Also, the use of publication or subscription services or lists that allow you to do things like actively update URL deny lists and IP deny lists that can be consumed by workers inside of all of the different accounts that exist inside of your environment. So in plain language, one way that you could deal with this is through deploying a Lambda function in every single account that your organization operates, and then consuming an SNS topic notification of a new update for a new entry that should be on your deny list. And one of the benefits to that is in a situation that's fast moving where we need to actively deny traffic to a known bad endpoint on the internet, we can send one topic notification out that will be consumed by all of the child members inside of your organization. So as an example of how to then blend all of this together, in this situation, we have an agency lead account on the left-hand side of the screen and an agency customer account on the right-hand side of the screen. And so the way that we would use this template that I just described is the template would be deployed inside of the account either through automated deployment using AWS organizations and stack sets, or it can be provisioned manually via a public distribution like a GitHub repository or through a private marketplace. And again, that template would first create that cross-account role that could be used by the security team on the agency lead side of the screen. Next, it would deploy a number of AWS config rules that allow the agency leads to understand the compliance as it relates to AWS security capabilities, but also, in the case of TIC3, the ability to derive direct mapping to security requirements. So in plain language, making sure that, for example, all volumes have encryption enabled, that S3 buckets are encrypted as a default. All of those things that we can automate, we can check the compliance using AWS config, and then also the ability to centrally create a deployment package that makes sure key security services are enabled. So in this case, you can see that we enable AWS Guard Duty, which can also, again, be configured to centralize those reports to go to a singular parent account. We can deploy those automations via AWS Lambda so that all of the automation that we want to deploy inside of the account can be done as part of the deployment of this template. And also things like making sure that every VPC that's in the environment has flow logs configured, enabled, and centrally reporting. At that point, we can also then beacon back the status of the deployment of this template to the agency parent account. So in this case, as a custom CloudWatch or a custom CloudFormation template function, the last step that would occur is an SNS topic notification that includes the account ID and other metadata about this account, letting the agency lead account know that this account has now fully provisioned the template that you've chosen to deploy, and that agency lead account can now use that cross-account role as well as expect data to start occurring from your account. For our US customers using TIC3, there is also the Cloud Log Aggregation Warehouse, or CLAW. For customers that want to make sure to meet their telemetry reporting requirements for the CLAW, they can also configure their account so that it centrally takes key logging sources like AWS CloudTrail, but also the ability to take operating system logs, Guard Duty threat intelligence logs, flow log data, and centrally provide them to, for example, the CLAW's S3 bucket. That's something that AWS and the DHS CISA team are still working on. So continue to stay tuned for updates in this space on the AWS Public Sector blog. The next area that we want to touch on is a sample overlay using a 3-tier web application architecture. And in this case, you can see that what we're going to do is identify key services that would be used as part of a trusted internet connection, or in this case, TIC3 design. So the biggest portion here is that we, again, focused on a zero trust model, make sure that we configure the connections to stay on the edge or as far out as possible. So we flow that traffic through Route 53 for DNS name resolution, and then we use CloudFront to serve static content and content that can be pushed to the edge. And then at that point, we would use services like AWS Shield and AWS WAF to limit traffic going inside of the environment. And we can also use the AWS Network Firewall as yet another buffer to evaluate traffic that has successfully passed through the CDN layer, passed through the WAF ACLs, and down to the application load balancer. And at each step of this process, when we communicate to the resources that are hosted at the back end of the application load balancer, we can also configure things inside of the VPC that allow us to create fine-grained, least permission access to resources such as those that are hosted in a service like DynamoDB. So what that allows us to do is, instead of just allowing all communications through the internet gateway to DynamoDB, we can use the VPC endpoint with a policy on the endpoint that allows explicit communication to a specific DynamoDB. Also, note that for each one of these steps, we can apply controls that allow traffic to flow only in directions that we want. So in this case, we have the security group that's referenced in the middle of the screen here. And that security group, for customers that are not aware, you don't have to just use CIDR range notation for that. You can actually use the security group identifier for that resource. And what that allows you to do is control the traffic to flow in a specific way. So in this way, traffic that goes to, for example, the EC2 instances on the right-hand side of the screen can only occur if it first passes through the application load balancer. And likewise, because that security group references the downstream application for example, the serverless applications that are on the far right of the screen, that prevents that direct communication with those resources because they don't share that same security group reference ID. As an example of a serverless application, similar design into the first portion, where again, we try to extend the edge out as far as possible, but in this case, we're also using Lambda functions for Lambda at edge capability. Much like previously, we flow that traffic through Shield and WAF to make sure that the appropriate rules are in place and that we're filtering traffic at that edge. But at this point, we can also use things like the API gateway. And from an API gateway perspective, we can also use services like AWS X-Ray to look at the code that's actually being executed on that Lambda function. So the control here is that because we're controlling access to that API endpoint in the serverless application, that allows us to have very fine-grained access to exactly the singular Lambda function that we want to expose, and then we can actually use look at the code that's being executed inside of that Lambda function. We can also chain downstream applications to that Lambda function, but rather than exposing them as direct Lambda functions, we can route that traffic through other downstream API gateways to, again, control and filter traffic that's going to those child Lambda functions inside of the environment or to other services like DynamoDB. And the idea, again, going back to the zero trust model, is that we try to break up the traffic at each step, making sure that there's proper identity verification and that we tightly control the process with a least privileged design. When we want to go to services that exist outside of the VPC boundary, again, this is where we can make, for example, cross-account role calls to other resources. And just like the previous example, we can extend that API gateway boundary design into those child accounts as well. So in plain language, what we can do is use a cross-account role for that, for example, Lambda function that's in the middle of the screen. And with that role-based access, allow it to directly communicate with, for example, an API gateway function that then only exposes a specific Lambda function. And the benefit there, again, is that we can constrain what we expect the traffic to look like at the API gateway layer, rather than allowing it to go directly to the Lambda function. For customers in the US, there was a requirement under OMB 2019 that laid out specific guidance for telework. For customers that are subject to that guidance, This is an example overlay using AWS workspaces as a mechanism to meet that requirement. And what this allows you to do is extend access to AWS resources such as virtual desktop infrastructure, but also the ability to communicate directly with resources in the VPC using that virtual desktop infrastructure in a way that, instead of using a VPN connection, uses the workspace's client. And what that's doing in the back end is using the PC over IP protocol. So instead of moving actual data over the wire to the client device, it's actually moving pixels back and forth. And it's important to call out that that also allows you to integrate with other directory services, both in the cloud as well as outside of the cloud, for step-up authentication or for additional authentication or authorization checks that can be performed at each step for a customer using resources inside of the environment. A quick call out on the Aws Network Firewall for customers that, again, are required to follow TIC3 guidance. A good way to think of the new network firewall solution is that you can think of it as sort of an Einstein 2 type device, in that it allows you to filter traffic at an IPS level, and that allows you to filter traffic at both an IP allow and deny, a DNS allow and deny, but also, really exciting, the ability to apply open source compatible rule sets like Suricata directly to the network firewall as well. That will allow you to filter traffic using the same functions that are in the network firewall that you would use on other inline IPS solutions that may exist inside of your environment today. For customers that want to get more information about how to use the AWS Nist CSF environment inside of your environment, there's a white paper that I'm putting on screen right now that will give you more prescriptive guidance on how to use the Nist CSF. And also, if you want to get more information about how to apply zero trust principles inside of your AWS account, I highly recommend that you watch the SEC 303 talk for Zero Trust and AWS Perspective. This gives a really great overview of Zero Trust and how AWS views Zero Trust. I want to thank you all very much for participating this year in AWS reInvent, and I wish you all well. Thank you.